Okay, so what we'll be having a look at today is, well, primarily having a look at the veranda details. So we had a quick look at eaves details on Monday. And because the detail there was fairly good, the one that's included in the Learn page is fairly good and fairly self-explanatory. I think we can roll with that. If you have any questions of Barry on attendance day, by all means do that. I think he'll have some eave details there up, and we'll chat about those further. He's a fantastic guy to pick his brain on some of those aspects as well. But push ahead with it. You guys, have you had a crack at any of the details of that yet? Not yet?
I started to look at the eave details on Revit. Yeah.
Cool. Yeah. So what will be, and so with that eaves detail, we don't really know what that top chord size is going to be. That's the truss manufacturer to work that out, and we can say that. We can say, as per truss manufacturer specifications, but we can assume it's going to be a 90-35 top chord coming down in that eaves detail, and the rest of those details we don't have to do any sizing up. But when it comes to the veranda, we do need to do some sizing up of timber members. Who here has not done timber framing yet?
I won't be doing it at all.
You won't be doing it at all? All right, okay. Yeah, because it's an elective, right?
Yeah. I've done the surveying.
Right.
I could change the curriculum, so.
Does that mean all of the rest of you have done timber framing?
Yeah, it became a compulsory halfway through.
Halfway through, yeah. So
Start of this year it became compulsory.
Okay, and you picked it up at that point.
Yeah. Great.
Cool. So a lot of this will make sense to you then, I hope. So our main information source for doing that veranda detail is going to be AS 1684, and this should be familiar to all of you, except maybe not really familiar. Army, do you have much experience with Australian Standard 1684?
Yeah, with you.
What's that? With me? That's like a veneer of experience. Yeah. No, that's okay. We'll go through it a bit more. And maybe with you I've mentioned stand tables and things like that already anyhow. So what we're going to be doing with the veranda on this place is, in cross section, we'll be doing something fairly similar to this scenario, where we've got our external wall, and then we've got our that location we've got a gable end there. So this is showing a roof slope gutter there. For ours, it's actually just going to be straight up like that, and we've got a gable over the top. So from this leader downwards is a bit more applicable to us. But we're going to be pitching off of a wall. We're going to have some rafters running to a veranda beam over here at the front, which is acting as a fascia to pick up our gutter. That's supported by posts, and then we'll have our purlins running perpendicular to our rafter to support our sheeting. We'll want to have purlins in a fairly similar sort of layout as they're shown in this detail, one quite close to this edge here to provide plenty of support for that sheeting close to the edge to stiffen that up, to ensure nothing's flapping in the wind. And then we've got about 1 metre span. Does anybody have the plans open there in front of them? I think we're dealing with approximately 1 metre span. 1 metre. Yeah. So what we won't be doing today is sizing it all up for you. I'm wanting you guys to do this yourselves at home, but we'll take you through that process. So I'll just be talking approximates for everything. So we've got, 1 metre span there, which is not very much at all, really. It's, might be able to do that with a sheet of paper, fold it a few times, but we'll find the right size piece of timber for doing that anyhow. Then that's going to be supported off of our wall by a pitching plate. That's really the best way to do it in this scenario. But I guess there's the possibility that you could mount your rafters directly off your studs here, and then work around that with your cladding. But it's just really very clunky, not very nice detail. A pitching plate really helps distribute all of that load. It works as a nice detail in with our weatherboards, and it's going to be very simple to work with and gives a great deal of flexibility. So we do a pitching plate here. Does everybody know what I mean when I say pitching plate?
No.
No? Richard?
I've heard of it. But
Heard of it? Yep, we want to see some pictures of our pitching plate. Okay, well I'll just quickly scroll down there. That one there is essentially a pitching plate. Now that's a little sketch of one that's been put in retrospectively. So we've got our weatherboards here, and then and a wedge in behind, like an inverted bevel, to help straighten the pitching plate up. We don't actually, because we're putting this in from new, we won't have this weatherboard here. That pitching plate will go straight onto our studs and fix into our studs, and then we'll be mounting our rafters off that pitching plate. And we'll want a pitching plate which is the right sort of size to fit in with our weatherboards there. So we continue this line of weatherboard starting directly underneath that pitching plate. If our pitching plate is a little bit short of our weatherboard up the top, that's a good thing, because we'll have a little bit of a flashing that comes from underneath this weatherboard at the top and folding over our veranda sheeting.
But does the pitching plate go the same length as what the weatherboards will be across that front wall? Or?
Well, it will, because our veranda extends all the way along. If we're doing a veranda which is shorter than that wall there, then our pitching plate will extend to the edge of the veranda, and we'll start the weatherboard at the edge of that pitching plate to look nice. Because otherwise, if you carry that pitching plate through all the way to the end wall, it'll just look like a bit of a jack-built sort of detail. So yeah, in this situation, we'll run our pitching plate from that wall all the way to the corner. So we're looking at a detail fairly similar to that, and then on the bottom side of this post, we're going to want to have some post stirrups. Certainly product agnostic, but one company that's fairly good to go to in terms of all of your metal fixings like this type of thing is Pryda, P-R-Y-D-A. Plenty of good information online, so you'd be looking for a PSFS 90. But yeah, write that down if you wish. So PSFS is Pryda stirrup, full stirrup 90 millimetre by 90 millimetre post. We need to have at least 75 millimetres of upstand of our post stirrup above our concrete there to ensure that termites aren't eating out our post, although we're going to use treated timber anyhow. But you want to have that there, both for termites and for bushfire. Well, for termites, bushfire, and also for just longevity of that post as well. So it's not subject to too much water and rotting out. So you need 75 millimetres minimum there, and then 150 millimetres in bedment. So you're looking at 225 millimetres in total. You can get those post stirrups with a 300 leg. So I reckon the 300 leg would be the one you go for. Beyond that, so we've got our sheeting at the top of our veranda. We're going to want to have a bit of flashing over the top. Now this is a flashing detail from a window. I just grabbed that off the Learn site, but it's appropriate to us here. I'll just expand that a little bit. So we're looking at that. Our flashing, basically all it does is ensure that any water coming down that wall is shed onto this roof here. So it folds out from under our weatherboard and then on top of our roof. If you have a look at the James Hardie website, the first picture there for their prime line weatherboards, if you look above that window there, they've got a flashing there, which is that's just a embossed polythene membrane flashing, the same type you'd use for damp-proof course and brickwork. I reckon you can do nicer details than that by getting one bent up. You can get one bent up at your sheet metal suppliers when you're getting all your roof sheeting and things like that. Designer flashing for that. I'd say, do I have? No, I don't have pens here to draw one up on the fly. But you probably get a metal sheet bent up to fit under that weatherboard that comes down on a slight angle. And then, cheers, thanks, Alan. Right, so we'll be looking at, this is our roof sheeting here like that, and let's give that about a 16mm depth. If we look at it from the end, we're dealing with this, right? Our weatherboard's coming in on an angle. We would want our little bit of a flashing to come there like that, come here, and then go down. And then if we're looking at it forwards on, our flashing would look like this, nicely scribed into our roof sheeting. That's the sort of detail which I think is a much nicer detail for your flashing, and you've got 2 bends on that, so it's not a very expensive piece of flashing. Your flashings get more expensive the more bends you do, and then you start doing some really odd stuff. Your sheet metal supplier might tell you whether they might tell you it can't be manufactured, etc. But does that make sense to everybody? That sort of bent up metal flashing. I think it's a nicer detail. Plenty of other things you can use as well. There's all these what do you call it? There's EPDM rubber with a sticky backing that you can use, very flexible, and you can bend that down into sheets. And there's tar backed tin flashings as well. So you definitely want to do a flashing above that. You don't want any water running down this face in here. It's not a huge issue in terms of say building protection or so, but that will just look really ugly. You tend to get more dust gathering underneath your verandas and things like that because it's dry. If you get water drips down through that dust, it just looks really horrible. So we'll be doing a detail here to show how this is happening. We're doing a detail there to show how that's happening, and then a detail here. That's pretty much almost exactly what you're going to be doing with that. Here where it says bolts as specified, if you look at the Prada catalogue, it'll tell you. Probably M10 coach screws. So with our AS1684, we've got a couple portions which we'll want to be looking at. We'll want to be looking at member sizes, because when we're drawing our details for this, we're going to have to know what size purlins we're using. We're going to have to know what size posts we're doing. We're going to have to know what size the rafters are, our fascia or our veranda beam, and our pitching plate here. So we're looking at member sizes, but then we'll also be looking at specific tie-down fixings. Doing a veranda, I think, does anybody know how wide the veranda is? We're about 2.8 or something wide. Everyone's got that in front of them. 2.8 or so, let's just say, pull that one out of the air. By 1 metre, we've got, very little uplift there, by 2.8.
3.4.
2.4? 3.4. Okay, 3.4. So we're looking at 3.4 square metres. It's really very little uplift at all happening on that. But we'll look at, it's not just about this, it's about working through this process for everything else in the future to come. But we also still need to check our tie downs for that. So for your veranda beams. So our veranda beams, that includes our pitching plate and our veranda beam at the front, which is acting like a fascia. So we've got veranda beams and in brackets plates. So that's what and so this is directly from AS1684, section 6.3.7. So, size of veranda beam shall be determined from span table 51A of the supplements for single span and continuous spans respectively, etc. We don't need to look at end beams or cantilevered beams. Ours is going to butt straight up to our fascia on the end. See this fascia here, or our veranda beam? We want to run ours butting straight into that, not cantilevering over the top for this detail, because we're supporting a gutter on the other side. Also, with your veranda beams, you do them in F7H3 LOSP. So F7, that's a stress gradient. It doesn't necessarily have to be F7, but I'll show you why I'm saying F7 in a little while. But it does, particularly our fascia bit on the end has to be H3 treated, because you're exposed to a lot of weather there. That H3 treatment, that's timber which can be used in exposed conditions above ground. So H3, and LOSP is light organic solvent protected. So LOSP is fine for using outside. You don't use LOSP internally in buildings because it off gases. It gives off something, I don't know what. So you don't use it inside, but it's great stuff for use outside. It survives the weather really well and has a lot of longevity. So with that veranda beam or fascia on the end, we'll be looking at a detail something like this, with our rafters butting straight up to it, and this one says tile batten, but that's it's good. I just grabbed a detail that looked correct, and well, that'll be our purlin there, and we want our roof sheeting. So we want our fascia to extend past our rafter by the depth of our purlin there. So if that's a 35 mil, we want this one coming 35 mil past, so our roof sheeting comes over top. We'll also want to have our roof sheeting lapping into our gutter by 50 millimetres. So 50 millimetres over, to ensure that any drips from our roof sheeting will go down into our gutter, that they won't get blown back against the fascia. With the mounting of that fascia on the posts, I want to see a detail like that. Whilst you see all sorts of details out there, you see posts coming straight up with fascias straight onto the edge of them. That's not the best sort of detail, because with that sort of detail you do tend to get more moisture harboured behind there. Whereas with a detail like this, you get less rotting out happening, but then you also got a very nice seat for that veranda beam or that fascia, because our veranda beam is probably going to be about 41 millimetres, and our posts are going to be 88 by 88. So that gives us 46 millimetres or 47 millimetres for the back section of our post here, which is plenty of strength for either bolting through or using coach screws. Typically, what's done is you use M10 bolts for it. Now you can use coach screws in that scenario as well, but bolts sort of clamp things better. The reason we want to go clamping things better is because in 20 or 30 years' time, when this does start to rot a little bit or fret a little bit, having it clamped together by bolts is a far more secure connection than a coach screw in that scenario. What we do have the issue with though is our gutter is going to be sitting here. So we'll either want to countersink our bolts or use cuphead bolts, so they pull in nice and flush, so our gutter can sit over that. The other thing, I'll scoot out just a little bit. I chucked in this weatherboard. Actually, I'll make that a bit larger and scroll down. So I grabbed our weatherboard from our technical brochure from James Hardy as well. The reason for that is, and I mentioned this on Monday, is that we need to look at our effective cover of our boards as well. So because we're doing our pitching plate on the wall, what we want to ensure is that our pitching plate fits fairly well into those boards. To help now we can use the same veranda beam as our pitching plate. Let's say we've got a 180 by 41 LOSP plate. We can use the same one, and then for our pitching plate on the wall, because we're only spanning between stud to stud, 600 millimeters means we can actually get away with a far smaller piece of timber. We can actually cut that piece down to the size that's required. So we can buy them at 180 pi, but carpenters on site can cut it down. The reason you want to cut it down a little bit is because we've got effective cover of 180 millimeters, so we want to be within that, but then we've also got maybe 35 millimeters for our purlins, so you probably want to trim 35 mil off your thing, plus just a tiny bit to ensure that your flashing at the top is on an angle. So when you go drawing in that detail at that wall junction, you can say that it's a 180 by whatever, cut down to. So it's this size, we buy it this size, cut down to that. That gives the carpenters on site that very clear instruction as to what timber they're ordering, what timber they're buying, and then what they're doing with that piece of timber on site. I'll put this in here, so there's a link. Well, it's not working as a link. Okay. Oh, okay. Well, and I'll cancel that. So it does work from slides. So when I put these slides into the Learn page, you can use that link. But I just wanted to show this as a bit of an example of what timber is available. Because yes, we can look at the timber span tables associated with AS 1684, and it's going to tell us we can use this piece of timber. But if we just use those pieces of timber, we go, all right, so we go to our F7 tables and it says use a 240 by 35 or so. We go, oh yeah, great, use a 240 by 35. We then go to buy a piece of LOSP and we notice we can't buy 240 by 35, we can only buy 235 by 31. If we specify 240 by 35, that means that the person buying that timber has to go the next size up, or get you on the phone and say, hey, we can't actually get the size that you specified. What do we do? So you go onto a site like Softwoods or so, and you've got all your dimensions there of the timber sizes as you can buy them. With your standard structural timber, so for those of you that have done timber framing, these sort of sizes will be very common to you. So 90 by 45 MGP10. That should be, you know, something that's no surprises to you. These are very standard sizes, so that's your non-appearance range. That's all the stuff you use for all your structural framing. These other ones, could anybody tell me what DA are? Oh, it says it up there. Okay, dressed all round. So that's timber that we're going to see. So all this non-appearance range, we've got knots and all that sort of stuff, doesn't matter. This stuff has been dressed up a little bit. That's what we're going to be wanting to use for our veranda, because we're going to be looking at it. And of course our LOSP, because our LOSP is typically used for verandas, decks, that sort of thing, much of it is dressed all round and primed. So you've got some sizes there. We've gotten to our timber span table, so this is for stress grade F7. Oh, that's right, I was going to tell you why we say for F7. No, okay. Well, it does a little bit here. So when you go onto, say, a site like Softwoods or Bone Timber or something like that, you'll notice that your LOSP primarily comes in primed F7. So because that's how we can buy it, we buy it as F7, not MGP10. We need to specify it as F7, not MGP10, because it's slightly different. Pretty similar sort of stress grade and strength of timber. We're doing very similar bits of timber, but we specify it as F7. So when we go to our span tables, use the F7 span table, not the MGP10 span table. So for veranda beam, Well, so we're at 3.4, so 3.4, but our largest span is about 2 metres, 2.2, let's say. Largest span of the veranda beam from post to post. Let's say it's 2.2. We've got